October 14th, 2020 Daily Math Review. Joy has 20 tiles, Kay has 28 tiles, and Liz has 44 tiles. They each arranged their tiles into a rectangle. They noticed that their rectangles had the same number of rows. What is the largest number of rows that their rectangles could have? So there's some keywords in here. Question: what is the largest number of rows that their rectangles could have? Oh, largest, greatest. Greatest common factor. So we don't need to use our least common multiple. So I'm going to delete that. You can delete it if you would like to. We are going to, however, find the greatest common factor. Now that we know what we're finding, we can figure out which template we're going to use. And in this case, it is the, a little too big. There we go. It is the greatest common factor template to help us. But now, what are we finding the greatest common factor of? Oh, well, Joy has 20 tiles. I'm going to highlight that in, we'll do that in blue. Kay has 28 tiles. Let's do pink. And Liz has 44 tiles. Let's do orange. So we need to figure out the greatest common factor, or the GCF, of 20, 28, and 44. All right, so here's what I'm going to do. I am going to kind of move these up a little bit so that we have a little more room. I'm going to put that title up there. Awesome. Okay, so we're going to have 20. We are going to have 28. And then we are going to have 44. All right, so we are going to find the greatest common factor of all three of these. Easy peasy, we got this. All right, so, okay, there's many different ways that we could do this. We are going to take a look and break down 20. So we can factor 20. What two numbers can we multiply together to get 20? There's two different ways here. You can either do 2 times 10, 10 times 2, 4 times 5, or 5 times 4. I'm going to do 5 times 4, or 4 times 5. All right, now, are either of these a prime number? Yes, that 5 is a prime number because, so we're going to circle it, because the only two factors are 1 in itself. It cannot be broken down anymore. It cannot be factored anymore other than 1 in itself. But 4, however, remember, we can break down this 4. We know that 4 is 2 times 2. 4 can be factored into 2 times 2. And we know that 2 is a prime number, so we are going to circle it. Make my circle a little bit smaller here. All right, perfect. So we know that 2 is a prime number because the only two factors are 1 in itself. There's no more branches to go. So our prime factorization of 20, remember, in order from least to greatest, we have a 2, another 2, and a 5. And remember, when we have our prime factorization, they are being multiplied. Because when we check it, 2 times 2 times 5, these prime numbers multiplied together will give us 20. So you can check it. You can say, okay, 2 times 2 is 4, then 4 times 5. Yep, that's 20. Bada bing, bada boom. What about 28? There's a couple different ways we can do this. 28. Let's do 7 times 4. Sure. You can even do 14 times 2. That's fine too. Let's do 7 times 4, or 4 times 7. Are either of these a prime number? Yeah, 7's a prime number. Why is 7 a prime number? Because the only two factors are 1 in itself, so you can't break it down anymore. But there's that 4 again. Woohoo! We like to break down 4 because it's easy peasy. 4, when we break it down or when we factor it, we get 2 times 2. 2 times 2. All right, is 2 a prime number? Bada bing, bada boom. Yes, it is. Because the only two factors are 1 in itself, so I am going to circle those 2's. All right, so now there's no more branches to go. So our prime factorization of 28 is going to be what? We have a 2, we have another 2, and we have a 7. All right, remember, these are being multiplied. Woo! There we go. Being multiplied. All right, now we have our last one, 44. What times what equals 44? Well, you could do a couple ways. You could do 22 times 2. I think of 11 times 4. Let's try 11 times 4. Or 4 times 11. Is 4 a prime number? No, look, we could break that down again. But what about 11? Yeah, 11's a prime number because the only two factors are 1 in itself. You cannot break it down anymore. But this 4, we do know how to break that down. 4 knows how to get it down on the dance floor. Woohoo! Break it down. 4 we can factor into 2 times 2. Yay! This 2 is a prime number, remember, because the only two factors are 1 in itself. So I'm going to circle those. So now there's no more branches to go. Prime factorization in order from least to greatest. We have a 2, we have another 2, and we have an 11. And remember, these are being multiplied. All right, now we're done with our factor trees. Let's take a look. What prime factors do they share? So all of them have to share the same thing. Do all of them share a 2? Yeah, they do. Woohoo, they actually do. All right, so I'm going to highlight that 2. So remember, we're going to match those 2's. What about another 2? Do they have another 2 in common? Yeah, they do. Let's do green. They have another 2 that they have in common. I'm going to highlight those. Do they have a 5 in common? No. How about a 7? No. How about an 11? Nope. So remember, we're going to take 1 from each pair. So 1 of these 2's, and we're going to take 1 of these 2's. So they share 2 2's. Haha, 2 2. So we're now going to multiply them. So 2 times 2. Well, that equals 4. So our greatest common factor is 4. But what is that 4 representing? For pillows? For blankets? Well, let's see. It says, what is the largest number of rows that the rectangles could have? So it would be 4 rows. That's it. Great job.